Good morning. This is your stats sensei, Mr. Spensey, and we're looking at a 2007B question 2. This problem deals with the binomial and also is an excellent explanation of the central limit theorem. So the graph below displays the relative frequency distribution for X, the total number of dogs and cats owned per household for the households in a large suburban area. For instance, 14% of the households own 2 of these pets. So basically 14% own 2, 24% own 1, 36% own 0, etc. According to a local law, each household in this area is prohibited from owning more than 3 of these pets. So anything from here up is not legal, anything but here below is legal. If a household in this area is selected at random, what's the probability that the selected household will be in violation of the law? Well, we want the probability that X is greater than 3, all right, where X is the number of dogs and cats in a house. All right, so that means we're just looking for the probability of X. So that means we're looking for the probability of 4 plus the probability of 5, ... to the probability of 7. So in this case, equals 0.07 plus 0.04 plus 0.04. And apparently no one has more than 5 cats, and they haven't met my cat lady score. So 0.07 plus 0.07 plus 0.04 plus 0.04 plus 0.02. Let me try that again. 0.07 plus 0.04 plus 0.04 plus 0.02. There we go. 0.17. All right, so equals 0.17. That's an easy point to get. All right. If 10 households in this area are selected at random, that's important. We have a specific number of trials. What is the probability that exactly 2 of them will be in violation of the law? So in this case, we have a specific number of trials, all right? And if we have a specific number of trials, then we have a binomial. And in this case, our trials equals 10. Our our p-value, our probability we calculated in part 1, we said, 17% are in violation. We want to know the probability that X equals 2. Probability that X equals 2. Excuse me. Yeah. Where X is the number of houses in violation. So in this case, we're only looking for an exact value. So we could have 0, 1, 2, 3, 4, all the way to 10. We're only looking for a specific value. I'm only circling 1, so this makes this a binomial PDF. This is going to be 10 choose 2, 0.17 to the second power, 1 minus 0.17, 10 minus 2 is 8. So there's my work shown. We're going to go to the calculator and we're going to go second vars, binomial, since it's a singular value PDF, trials is 10, P is 0.17, X is 2. And we end up getting 0.29, 0.29. try that again, 0.2929. And binom PDF trials equals 10. P is 0.17. X equals 2. All right, so that takes care of that part. All right, and again, that's a fairly easy one to get. So the mean and standard deviation of X are 1.65 and 1.85 repeatedly, so respectively. So let's write that down. So this is my mean, or label them. This is my mean and my standard deviation. Suppose 150 households in this area are to be selected at random, and X bar, the mean number of dogs and cats per household, is to be computed. Describe the sampling distribution of X bar. All right, so we want the sampling distribution of the mean, including its shape, center, and spread. Even if they hadn't asked for shape, center, and spread, they've only asked for to describe the sampling distribution of X bar. If they had left off this, I know I need to cuss because it says describe. So I need to cuss. So I need to talk about the center. All right. So the mean equals the mean is the mean is the mean. So I don't have to change anything on that. All right. So the mean is, in this case, 1.65. The standard deviation of X bar is the standard deviation divided by the square root of n. And this will always be true regardless of the sample size. So 1.851 divided by the square root of 150. So let's do that quickly. 1.851 divided by 150. I'll raise that to the half power. And I end up getting 0.1511. So there's center, there's spread, shape, normal. All right, I need to talk about why it's normal. The distribution of the means of the sample means is normal by central limit theorem. Why? Because n is greater than 30. So please notice, real important to completely cuss this out. We don't need to talk about the unusual features, but center, shape, and spread, or center, spread, and shape, as the case may be. So there's my mean of 1.65. There's my standard deviation and normal. So distribution of the sample means is normal by central limit theorem because n is greater than 30. The mean, and by the way, I haven't put this in context of, so I need to make sure I put it in context. The mean of the sampling distribution of X bar of dogs and cats per house is 1.65, and the standard deviation is 0.1511. They told me to describe, so I'm I have to make sure that I always contextualize. All right. Thank you for watching. I hope that helped out a lot. Talk to you later.